Welcome to Approximation and Errors. Often when we do calculations, we may end up with numbers that have many digits, some of which we may deem irrelevant. In such instances, we either truncate the numbers or round them off to a given number of significant figures or decimal places. When we do this, errors are incurred. Significant figures. Approximation can be made by expressing a number to a given number of significant figures. Significant figures in a number are counted from left to right, starting with the first non-zero digit. In Form 1, we saw that the digits 1 to 9 are significant. 0 may or may not be significant depending on its position in a number. For example, these numbers indicated below have the respective significant figures shown. Whenever we want to round off a number correct to a given number of significant figures, say 3, we count the first 4 significant figures starting from the left. Check the fourth significant figure, and if it's 5 or more, add 1 to the fourth significant figure. If it is less than 5, we retain the fourth digit and replace all the others after the fourth digit with zeros up to the desired place value. Consider the number 0.00452060. The digits with asterisks are significant. If we round off the number to the respective significant figures, we shall have the following. Truncation of numbers. Truncating is basically chopping off digits of a number to respective significant figures or decimal places. For example, truncate the following to 2 and 3 significant figures and decimal places as well. If we do that, we'll end up with the table shown below. When truncating a number, no digit is altered irrespective of the digit after the first one, that is, no rounding up. Rough estimates. These are estimates used to find the approximate value of calculations. It involves rounding of numbers to a given significant figures to ease the computation. For example, give the rough estimate of 16.1 plus 6.3 over 9.9. We can approximate that to 16 plus 6 over 10 to give us approximately 2.2. Square root of 16.09 times 8.99 can roughly be given as square root of 16 times 9, and we shall get roughly 12. Errors. The difference between the approximated value and the true value is called an error. Truncation errors. When we truncated the numbers in our previous example, we incurred errors. For example, truncating 3.9284 to 3.92, the truncation error is 3.9284 minus 3.92, which gives us 0.0084. Errors in measurements. Whenever an instrument is used to measure certain physical quantities, for example length, the accuracy depends on the sensitivity of that instrument. Accuracy is the closeness of the measured value to the true value. Sensitivity, on the other hand, is determined by the smallest value an instrument can measure. For instance, a ruler can measure up to 1 millimeter, hence its sensitivity is a millimeter. Therefore, when using a ruler, we cannot have a value of 0.1 millimeter. It will be misleading. Rounding errors. Suppose the length L of a metal bar is approximated as 20 centimeters. We say that this length lies between 19.5 and 20.5 centimeters, such that 19.5 is less or equal to L, which is less or equal to 20.5. This approximation has a rounding error of plus or minus 0.5, written as 20 plus or minus 0.5 centimeters. How we record the measurement indicates the accuracy of the measurement. For example, if the above was approximated as 20.0 centimeters, it means the measurement is rounded to the nearest 0.1 centimeters. Hence, the error is plus or minus 0.05 centimeters. If it was 20.00, we shall have an error of 0.005 plus or minus, since the measurement is rounded off to the nearest 0.01 centimeters. Over to absolute error. All measurements have rounding errors with positive and negative sides. For example, 2.6 kgs has an error of 0.05, 6.92 an error of 0.05, and so on. The absolute error is half of the smallest unit of the measuring instrument. For example, for the above case, 2.6 kgs, the smallest unit is 0.1 kilograms. Absolute error is a half of 0.1, which is equal to 0.05. 6.92, the smallest unit is 0.01. Absolute error is half of that, which is 0.05, and so on. Relative error. The fraction absolute error over actual value is called the relative error. Example using the above cases: 2.6, the absolute error is 0.05. Relative error is 0.05 over 2.6, which is equal to 0.1923. Equally, 6.92, the relative error is 0.005 over 6.92, which is equal to 0.0007225. Percentage error. This is the absolute error expressed as a percentage. That is absolute error over actual value times 100%. For the above cases, we shall have the following as shown below. Take an example. State the sensitivity of an instrument giving a value of 29.54 seconds. Give the absolute, relative, and percentage errors to three significant figures. The smallest unit is equal to sensitivity and is equal to 0.01 seconds. Absolute error is half of 0.01, which is 0.005. Relative error is 0.005 over 29.54, and percentage error is 0.005 over 29.54 times 100, which gives us 0.0169%. Propagation of errors. When measurements are used in calculations, their errors are carried on to the solution. This is propagation of errors. Addition and subtraction. For example, 4.4 kilograms plus 3.2 kilograms and 2.11 centimeters plus 2.34 centimeters. For A, the limits of measurements are 4.4 plus or minus 0.05 and 3.2 plus or minus 0.05. Maximum possible sum is 4.45 plus 3.25, which is 7.7. Minimum possible sum is 4.35 plus 3.15, which gives us 7.5. The actual value is 7.6 kilograms. Absolute error is given by maximum minus the actual, or actual minus the minimum, and we shall have 0.1 kilograms. For B, the limits are found just as A, maximum equally, minimum the same, and we find the error as 5.46 minus 5.45, which is 0.01, or 5.45 minus 5.44, which is also 0.01 centimeters. The absolute error in the sum is equal to the sum of the absolute errors in each measurement. Example, 8.3 millimeters minus 6.4 millimeters. The limits are just as we did before. However, the maximum possible difference is 8.35 minus 6.35, which is 2 millimeters. The minimum, on the other hand, is 8.25 minus 6.45, which gives us 1.8 millimeters. The actual value is 1.9 millimeters. The error is 2 millimeters minus 1.9, or 1.9 minus 1.8, both of which give us 0.1 millimeters. The percentage error is 5.26. The absolute error in the difference is the sum of the absolute errors in each measurement. Note that For maximum difference, we take the largest possible minus the smallest possible. For minimum difference, we have the smallest possible minus the largest possible. Multiplication and division. Multiplication and division is carried out equally just as we have done. However, note that for minimum computation, we take the smallest divided by the largest. For maximum computation, we take the largest divided by the smallest. That brings us to the end of approximation and errors.
Choose a path, choose a direction, choose your day, choose your hours, choose to network, choose a strategy, choose to create, choose your media, choose to care, choose to inspire, choose to listen, choose to learn, choose to train, choose to compete. Newcastle College, why choose anywhere else?